been in existence for over 15 years, and once a student graduates from high school, because it's a K-12 program, technically they're not a GLOBE student anymore, and so some of our students actually self-organized and created the alumni network. So we have a group of alumni who are working to recruit other alumni and help support local schools. So it's really, I think, a testament to how much teachers and students really enjoy the program and see the benefit of working collaboratively around the world. Because we are an international program and because we have the bilateral agreements, we are obligated to actually provide all of our materials in each of the UN languages. Right now, China is an inactive member of GLOBE, and so we don't have all of our materials in Chinese, but we do have a lot of the materials available in the other 5 UN languages. And we also have some countries who are just want to be able to use the materials, so they've translated the materials on their own. And on the right, you can see there we actually have a whole website that talks about how to take the GLOBE program and integrate it not just through science but across the entire curriculum, which is becoming really important for U.S. teachers because there's so many demands on their time and they have to figure out how this all fits together. Over the 15 years, just really briefly to give you an idea of what GLOBE materials we have, there are a tremendous amount of resources that range from storybooks for K through 4 to secondary school resources of Earth System Science posters that show how various variables change over the course of a year: insolation, temperature, cloud fraction. We have some online learning modules. We're working on developing more for teachers. We have GLOBE cloud charts that are available in all the UN languages that we provide to teachers so that they can go out and help their students identify clouds. The core of GLOBE. Say again?
They're all the materials are on the web and free?
Yes. So the materials are online, and right now I'll qualify that with some of them are a little bit difficult to find because we're in the process of transitioning to a new website. Our new website's going to launch in November or early December, and it'll be much easier to find all these materials. But everything is available online, and it's free. You can download it and use it however is most appropriate. Over the years, we've developed out 5 areas of investigation that they're called that really focus on Earth system. So atmosphere and climate is kind of the most popular because that really goes across a lot of grade levels. Hydrology, land cover biology. Phenology, which is like, if you're not familiar with it, it's like bud burst or green up, like when all the trees turn green, or green down when the leaves start to fall off. And obviously those don't apply everywhere in the world. And then soils. And so we actually have protocols, so instructions on how to collect data about all different kinds of variables: clouds, aerosols, air temperature, water temperature, soil temperature, pH. So we have a set of instructions, and when a teacher goes to a training session, they are trained in how to collect data, what kind of instruments they need to use, how to calibrate the instruments. And once they do that, they understand that the importance of calibration. They know how to collect the data, and then that data is entered online into the database, which we house here at the GLOBE program headquarters in Boulder. And over the 16 years, the students from around the world have entered millions and millions of data points. To go along with that, we have activities that they can do in the classroom, so learning activities that help connect the data collection with other things that they're working on. We also work very closely with a lot of the NASA satellite missions. So you can see CloudSat there, that icon. CloudSat is a satellite mission that is exploring clouds at different levels. So if you think of a typical satellite, they see the cloud that's at the top, but you don't know how many layers of clouds are below or how thick those clouds are. And so what our GLOBE students are doing is they're actually doing ground truthing. So they go out with a convex mirror and take photographs from the bottom, from the Earth looking up, and then the scientists look at those data and compare them with what CloudSat is seeing from the top down, and they're actually working together. And we also have a lot of Earth system science projects that help students connect the different spheres of the Earth system together. This just gives you an idea. This is actually a list of all of our protocols in the different investigation areas, and a lot of them are relatively easy to do. Some are a little more challenging, and depending on what time a teacher might have in the classroom, they could do something as simple as looking at the clouds, or they could try to figure out the dissolved oxygen of their local waterway. Here's an example of CloudSat. The slides are a little out of order, and you can see the groups, the students out there, and they're around the world. The scientists actually travel to all these different locations as part of the education and outreach for the mission. The first ground truthing that was done for GLOBE was done with the Landsat satellite. Something that you all may have heard of is GLOBE at Night, where we actually ask the GLOBE students to go out and take observations to look for light pollution. This is really caught on in Europe and Argentina in particular, and of course the U.S. is a big participant as well. At the office here where I'm at, we try to coordinate some things and provide kind of general activities that people could participate in, teachers and students and scientists could participate in around the world. So we kind of developed the framework, like I said, put it out on the web, give some guidelines on how they could participate, and then each teacher determines whether it fits with them or their curriculum or not. And if they participate, they enter data into the database or send us some feedback so that we have an idea of participation overall. But it also lets them kind of adapt things to their local curriculum. A lot of our goal is to have students look at the environment from that scientific perspective and try to make their local community better. And the best example that I can give of this is actually some student research that was done by GLOBE students in Benin, Africa. And they actually wanted to look and understand more about how malaria is connected with the weather. And part of the reason why I love this example is because, especially in the United States, we have a lot of technology available in schools. Not all of them, but a lot. But here they're actually using graph paper, and they don't have a lot of technology, but they're still able to participate and explore their local environment. So they plotted out over the course of a year, the x-axis is a year, month, the cases of malaria, and then they used their GLOBE protocols and they collected temperature data and precipitation and they plotted it. And they tried to they did a research project to determine what the connection is between temperature and precipitation. And this may not be that revealing to all of you or to myself, or we kind of intuitively know this sort of thing. But for students, this is really empowering. They're realizing that there's connections between what happens in their community and in the environment, and that they have some ability to actually contribute to that, and so they could help educate the local community. The most recently, the GLOBE program is actually trying to provide a little bit of a focus on climate, and we're really kind of promoting climate, understanding climate, and from that, students can then take that a step further and look at changes in climate globally or locally. But we're really trying to just get people more aware, understand the difference between weather and climate. This is a really significant challenge in the United States. We're trying to help students ask those scientific research questions to help them keep that inquiry process going. And we're trying to provide a very timely mechanism to increase collaborations between scientists and schools. So one of the things that we're doing is we're basing our climate initiative on the Climate Literacy Principles, which is an interagency document that was produced, which is pretty impressive that all of the agencies in the U.S. were able to come to agreement on what are the core things you should know about climate. And as I mentioned, we had this World Water Day event, and it was pretty incredible. This was our first attempt at getting students to think about climate. And you can see examples of all the schools around the world, really, who were reaching out to their local communities, and if they participated, we gave them T-shirts, which is not an insignificant task when you're when you have that many students involved. The last thing that I wanted to just say about our campaign, we're trying to support a global initiative on exploring climate, which is incredibly difficult because climate's different everywhere and everyone has different challenges. So we're developing a framework that will be available on our forthcoming website that helps teachers research climate, to help collect data to support understanding climate, and also provides them some climate foundations on how they can actually better teach it, understand best practices and the pedagogy. And our goal is to get scientists involved and have the scientists and students working together to produce new scholarship, which is something that's happened in the past quite a bit. Our climate initiative is actually launching in September, so in about 6 weeks. Just a couple of things that I wanted to kind of point out, some highlights. So we've had some global recognition. We have publications, peer-reviewed publications, both on the science that's been done in GLOBE and on the instruction, the pedagogy. And PISA has recognized that in Finland in particular, the GLOBE program and the ENO program, which we work closely with, have actually helped to improve the students' understanding in science. It's very difficult to measure student achievement